All right, welcome to the number and quantities group video. Our first slide just showed our learning outcomes so students know what to expect as we continue throughout the lesson. We provided guided notes, so this was just a reminder to take out a pen and follow along. Shout out to Professor Algren. He helped us create some of these problems and helped us create our lesson. Okay, our first topic that we covered was bases. Traditionally, when we're doing math and taught in elementary school, we think of it in a decimal way, which is base 10, but we also introduced binary and octal and hexadecimal, which is base 8 and base 16. So the first thing we did was taught our students how to convert something like in a different base. So for example, in the first problem, we were converting 1001 base 2 to base 10. So we went over that problem in class and then gave the second example for them to try on their own. And then these are just the answers so that they could check. And then this is the work. We then tested our students to ask if this was allowed, and they were very good at realizing that it is not allowed because we can't have bigger numbers than the base. So like 3 and 4 can't be in this long number because base 2 only uses numbers 0, 1, and 2. Then we went on to converting the other way. We started with a number in base 10 and then converted it to a different base. For example, we did it to base 2 to just keep it easy to start. And then we also gave them another example to try on their own. And then this was the answers. And then this just showed the work. Then we had them practice with a different base other than 2. In the previous few slides, we just had them convert between base 2 and base 10, and this one was a little bit more tricky because we had them convert from base 8 to base 10. Then we had an activity where they could convert their birthday into base 3. So everyone took their birthday and converted it and got different answers, and it was a fun activity. All right, this slide talks about a way that we can kind of generalize what we were doing in the last few problems, especially since we're all math majors. It's a little bit more clear to sometimes see it written out in this form. Next, we went on to adding bases now that we're comfortable with working in different bases other than 10. So again, we went through a problem on the board, and then we had them try the second example. And then that was the answer for the first one, and that was the answer for the second one. Then same thing, we did subtracting bases, so we went over an example, and then we had them try on their own. And these were the answers. And then we also did multiplying bases, which is a little bit more tricky, but we still went through an example, and then they tried on their own. And then we went over this one as a class as well, the second example, because it did take a little bit more time and it was a little bit more challenging for students. And then these were our answers.
Hi everyone, we're going to be doing congruences and modular arithmetic now. Okay, so to introduce congruences, we're going to look at a real world example first. So when you're thinking of a clock, we're actually using modulus because we're technically like, I guess you can like connect it to bases, but it's kind of like making the base 12. And once, like for example, if we have 13 in this case, it's going to be 1 mod 12 because there's one remainder. So here are some examples we had our class try as a good warm-up. Next up, we also looked at it in more of just like more of a problem scenario. And then we kind of like put it into mathematical terms here. So it's basically you can subtract the number on the right side from the left side and just solve for these problems like so. Here are some more practice questions. We had our class do more practice here. And then here are some important properties of congruences. These are very useful because when you're trying to find like the congruence of like a very large exponent, you can actually use congruences without using your calculator. And actually, sometimes the numbers are too big to even use in like a normal calculator. So I think these are very like useful techniques. And then we had our class go through this problem, 9 to the 15 plus 5 to the 12. We went over this in class, and you can try these at home. And that is it for mods.
Okay, now we're going to talk about day 2. And these are learning outcomes. So number systems and complex number systems. So we started out the day with a warm-up activity by practicing some of the stuff from day 1. So number systems. It basically consists of natural numbers, integers, rational numbers, real numbers, and complex numbers. And we looked a little more in depth into complex numbers, which are a combination of real and imaginary numbers. And we practiced it by graphing it on the x and y axis. Okay, we learned about the Mandelbrot set, and you can learn a bit more about it by rewatching this video. Okay, now we practice trying to find out if a few numbers belong in the Mandelbrot set, and we know that a number belongs in the Mandelbrot set if it is recursive or if it repeats itself, and if it goes towards infinity, it's not in the Mandelbrot set. Okay, imaginary and complex numbers. So imaginary numbers are expressed as the square root of -1, and basically I squared, I to the power 3, I to the power 4, like it repeats itself, and you can use this pattern to simplify this following complex numbers, and we practiced a few.
Hello, we also covered vectors in our lesson, and to start off the lesson on vectors, we gave a definition, which is a quantity with both a magnitude and a direction, and we connected it to the real world by making a connection to velocity and acceleration. We went over vector addition and vector subtraction, and we also went over scaling vectors and how we can scale a vector to change the length, or we can also change the direction of the vector. We went over dot product and cross product, and to practice these, we gave an example to the class and we went over their solutions together. To practice the concepts we learned about vectors that day, we did a vector activity on the quad where we split the class into groups, and each group was responsible for measuring a different side of the quad by counting the squares on the sidewalk. And after everyone's done, we used everyone's measurements to come up with a map of the main quad using vectors. The next day of class, we went over matrices and a little bit of linear algebra. These were the learning outcomes of the day, and we started off class by giving information on our quiz, which was given to the class the next day. This was the map from the vector activity where we used everyone's measurements to come up with this coordinate system. Since we didn't have enough time to do a complete review during class on matrices, we gave a Jeopardy instead. The lesson we gave that day was on the Fibonacci sequence and linear algebra. We started off by giving a definition of the Fibonacci sequence and the golden ratio, and by using concepts from linear algebra such as eigenvectors or characteristic polynomials, we derived a single matrix that can be used to express the Fibonacci sequence. And that was the end of day 3 and our lesson.